Okay.
Maybe it's just a display error.
Could be. All right. Well, let's go ahead and get started. You can see whenever the door closes, it just got bam. It saturates the mic. I should just set it to a lower setting. All right. So we have a full day today because I have to cover the homework assignment that was due 1 minute ago. And then we have to talk about the practice exam. The exam is going to be open book, open notes. Okay, so you should keep that in mind so that you can prepare your own notes with you. You can bring anything you want. You can print out my notes and bring it to the class. You can go out to the library. If you can find a book that you think is going to be helpful, you can bring that too. But just look at your desktop right now. This is how much space you will have on the day of the examination. Exactly, your elbow is going to, touch someone else's elbow. So my advice is to study the material, and what you want to do is to condense the notes to something that is much more manageable. Yep.
Could we use the practice test?
Oh yeah, you can bring the practice test. You can. The only problem with the practice test is the actual test is similar to the practice test in some ways, and in some ways obviously it's not going to be the same. So in order for you to bring that in, to help you, you have to remember, it is not going to be the same. So you have to force yourself, to say, okay, it's not the same because sometimes it may look similar to the practice test. So the recording is up, so that's good. And let me pass the roll sheet. And then we'll go over the homework assignment first. That's the first thing we'll do, is to go over the homework assignment. The homework assignment is kind of similar to the previous one, but the previous one only has assignment statements. This one has a conditional statement that includes assignment statements. But the additional stuff that you have to do is actually fairly minor. So let's go ahead and start with this one, and then we'll move on and talk about the practice exam. I'm hoping that we'll have enough time to cover everything today. All right. So first thing first, I'm going to copy and paste this into my editor here. The formatting gets all over the place. That's okay. We can fix that. All right. And the funny thing is, it even copied the non-ASCII character, the left arrow symbol got copied too. The question is, can you open it in WordPad and it still shows as a left arrow? No, so that's not. In that case, we can change it. So once again, this does not mean x is less than net minus x minus y. It is a left arrow. It's an assignment operator. All right. So let's go ahead and get started. Pre-1 is given to you already, because otherwise you cannot get started with this homework assignment. And once again, pre-1 is not true. Okay? It is not a simple true. I think only one person made that mistake in the previous assignment and said pre-1 equals true, because I think most people remember that I actually give you a pre-condition. I personally will start with pre-2 and pre-4, but you can start with pre-2 and then work on post-2. Excuse me, you can start with pre-2 and then post-2, pre-4 and then post-4. So the order is up to you. Now pre-2, the first line we have to say it is pre-1 and the condition of the conditional statement. Okay, I'm looking for this line because I want people to understand this is because of the structure of a conditional statement. Okay, it is not because line 2 is sequential to line 1. It is because they are, because of the structure of a conditional statement.
What?
Yes?
So now it's not sequential line 1? I wrote it was, so that's wrong.
It's not because they're sequential that you get this as pre-2. Pre-2 is Pre-2 is like this because of the conditional statement, because you have to take a branch, and when you take a branch, you have not had a chance to change any of the variable yet, but you have confirmed that the condition of the conditional statement has to be true.
How do I annotate that when I'm doing the test?
You don't have to do anything. This is fine. Yep.
Should you use a post one so that you tell it that pre-1 and
I would not use post one. As I explained in the class already, I would not use post one because this really designates what is going to happen before line 2 executes, and as a result, there's no post 3 either. It's because when you take a branch, it is not post 1 because it is not sequential to line 1. We choose to execute line 2 only because the condition is true.
okay, but could it be pre-1 and I don't know how to explain it. That's okay.
I probably won't take any points off if you say post 1, in the homework assignment.
Yeah,
but
I see.
in the test, you want to make sure that you do not refer to it as post 1. Even though structurally, or if you look at the line numbers, it seems like post 1 is just as good as pre-2. But in terms of the structure of the conditional statement, you should designate it as only pre-2. And this is fine. All I want you to do is to understand that we have the additional condition to tag on to whatever pre-1 was, and this is fine. There's no need to simplify anything. Even if you identify something that can be simplified, don't bother to do it. It's not necessary. So personally, I would do pre-4 at this point too, because structurally speaking, pre-4 is very similar to pre-2. It's just that the condition is negated. And that's why I would do pre-4 before I go on to post-2 or post-4. So for the most part, you can even copy and paste. It's just that when you copy and paste, you have to remember to negate the condition, because you don't go to the else branch unless the condition is false. Yep.
Can you say x is less than y there, or no?
I would do that in the next line. If you do it on the same line, that's fine. This is not a big deal. So I'm not going to take points off, because of those, minor little things. But I would do it in the next line because I want to show myself why is it, it is x less than 4, because x is less than y never appeared in the original code. So I want to make sure that I leave enough trail for myself so that I can explain why it is x is less than y. It's because it is the negation of x is greater than or equal to y. Okay? In other words, I'm not skipping any steps. I'm making sure that I have all the steps closely spaced, and I'm not jumping over any steps. So that's fine. And then the rest of it is actually just assignment statements. Okay? Because we have line 2 being an assignment statement, self-referencing, and we have line 4, which is also an assignment statement, and it is also self-referencing. I mean, does x refer to x?
Yes.
Yes, it does. And for those of you who are not convinced that this is actually a self-referencing assignment, you can actually do something like this to convince yourself, because we have x gets x plus 1, we know how to deal with that. This is the same thing as x gets x plus 0. Or, if you prefer multiplication, it's the same as x times 1. So it really is the same thing as what we have been dealing with, except this one is actually simpler in many ways. So now we want to derive post 2, but to derive post 2, you have to go through all the same motion as in your previous assignment. So the first question you have to ask is, does the right-hand side of line 2 refer to the left-hand side? But I already said, yes, it does. Then the next thing you have to do is to state that it has an inverse and what the inverse is. Some people forgot to do that in the previous assignment and just skip to the substitution right away. I only take 1 point off because of that out of 30. So it's just one little step, but I think it is important to state that before you decide to use the substitution rule. Okay, so all you have to do is to say an inverse function exists, use the substitution rule. Even that is enough. But I would make it more clear and say f of x, which is the right-hand side, is x minus y. So the inverse function x prime of x is x plus y. opposed to the first line is really just a template line. The template line is just stating how everything relates to each other without actually going into the details. So we substitute occurrences of x with f prime applied to x. And then the rest is just expanding 3-2. 3-2 is, yep, go ahead.
Sub 3-2x f of x, f prime of x equals x plus y.
Say again?
Parentheses.
Say again, on which line?
17.
On line 17?
Sub 3-2x
This is
f prime of x equals x plus y.
F prime of x is defined as x plus y, and that's why we have x plus y over here.
Right.
This line is a template. This line is specific to this particular case.
Where you actually put the x plus y in there and everything.
Oh yeah, we expand, what pre1, pre2 is. We expand what is f prime of x is. So the second line expands everything, and then the third line is just a blind substitution of everything. Unfortunately, my editor does not support search and replace within the selected text, so I'm going to have to do it the hard way. And unfortunately, because we are taking this test on paper, you have to do this, on paper. So that's going to take a little bit more time than, copy and paste. Okay. Yep.
How come x plus y is less than 2 times y? And I had a thing with that when I did it, right? Because look, if you minus y off both sides, it's going to be x is less than y. But in reality, x is greater than or equal to y in this thing. And that's what I got confused in the homework. So I just changed it. On
There's no statement saying x is greater than or equal to y.
Yes, there is. It's in.
On line 19?
It's on line 18. It says it's either.
Yeah, but that gets changed to x plus y is greater than or equal to y, which simplifies to x is greater than or equal to 0.
So I did some creative and I messed up. Got my own throat.
Well, I'm giving partial credit as long as one step. As long as this step follows this step here based on your f prime of x, I still give you partial credit for that.
So you just plug it in even though it's actually wrong?
No, it's not. There's nothing wrong here. There's nothing wrong.
Okay.
The original condition is x is greater than or equal to y.
Right.
After the substitution, it becomes x plus y is greater than or equal to y. There's nothing wrong with that. Because if you subtract y from both sides, all it is saying is x is greater than or equal to 0. There's nothing here that conflicts with that statement. So it's perfectly fine.
So that's why you just leave it as is, don't.
Yeah, I just leave it as is. Yep, that's all I'm going to do. Yep.
You must have simplified the test.
Sorry?
You must have simplified those on the test, like the x equal x is
You can simplify it, but it's not required that you simplify it. Because, I would not simplify, because if you simplify and you make one mistake in the simplification, then it is potentially possible that I would take points off out because of that. Yep.
Okay, on the same line, 19, look at the, right before x plus y is less than 2y.
Okay. X plus y is less than 2y, yes.
And if we subtract a y off each side, you have x is less than y.
Yes.
And the condition is x is
You
equal
can't
to
subtract
y.
one, because one's multiplying one's addition.
No, but this is y plus y, so it is possible to simplify this to become x is less than y.
That's what confused me. That's
But that does not conflict with anything else. There's nothing else here that it conflicts with.
So you just leave it and don't simplify.
Yeah. Well, I mean, if you simplify, it's okay because let me just take this up one. Okay, so optional. Okay, which means you don't have to do this step here. X plus y is greater than 0. Okay, fine. Y is greater than 0, not a problem. And this one simplifies to x is less than y.
Right.
Which is fine. Nothing. It does not conflict with anything else here. And the last one becomes x is greater than or equal to 0, which also does not conflict with any other conditions here.
But it conflicts with line 18, but that doesn't mean anything.
Well, of course no, it does not conflict with line 18. line 19 and therefore line 20
Right.
is derived from line 18. The application of the substitution operation ends up as line 19,
Right.
and then one more simplification ends up with line 20. This is all mechanical. Line 20 is the optional line, which requires a little bit of algebra, but everything else is just completely mechanical. You look for x, you replace it with x plus y, you're done. And that's because of the nature of the beast. So
Right.
you have to go back and remember why we are doing this. Okay, any questions from you guys? Any question? No? Okay, if you have any question, just kind of bring it up.
Advice, don't be creative.
Don't be creative. Well, just kind of stick with the mechanical method. There's a
Right.
reason why, I make it so mechanical, just so that you identify which rule you have to apply, you apply the rule, and you're done.
Okay, one
Yeah.
last question, I don't mean
Yes.
to keep asking. So, would you say line 19 and 20 are the inverse and line 18 is like the main one or whatever?
This is the template.
Right,
This is expanding what is pre-2 and what is f prime of x.
okay.
This line is the result of the actual substitution.
So that would be considered post 2?
They are all post 2. These are all post 2. That's post 2. This is post 2. This is post 2. And this is also post 2. It's just post 2 in different stages of the derivation.
Okay, I think I got it.
Okay. All right. So post 4 is very similar, okay? Because with post 4 is actually in many ways simpler because the function x is the function is just f of x is x. So, but we still have to ask the same question. So I'll just go ahead and copy and paste this part here. Does the right hand side of line 4 refer to the left hand side? Yes. And then we have to state f of x is just x. So that means f prime of x is also just x. Okay. So that makes things a whole lot easier because when you try to derive post 4, you do the same thing here. You apply the substitution on line 4, the precondition of line 4. You replace x with the inverse function applied to x. Do you guys have a question? Because I can hear you, and so can the recorder. And I can prove it too. So in this class, it's all about proving. Everything has to be provable. Okay, so pre-4 is this mess here. And then we have x, we have f prime of x, which is just x here too. So you can see that I am using the most general method to do it. I'm not reasoning it out and say, oh, x gets x is just a null operation. It doesn't really do anything. I did not go that route. All I'm doing is blindly following my own rules and apply these substitution operations blindly. And the result of the substitution, and I can even do that here, even though it is a useless operation, I can substitute x with x. Okay? Because I want to emphasize the fact that you only have to follow the rules mechanically and the rest will just follow. Okay? In computer science, we particularly like things that are rule-based or template-based. If it fits this pattern, you do it this way. If it fits this pattern, you do it this way. Because once we can do that, you can instruct a machine to do it. On the other hand, if you have to rely on rules of thumb or heuristics, then those knowledge becomes much more difficult to be encoded so that the computer can do it. So we like mechanical stuff. Okay, so now we have post 2 and also post 4, and now we can work on post 5. Just saying that post 5 is post 2 or post 4 will get partial credit, because that is because of the structure of a conditional statement. And then the rest is really just copying and pasting. So I'm just copying and pasting the original form, and also this one here. And I don't even bother to do any type of simplification here. I just leave it the way it is, because in this class I'm not teaching Boolean algebra. I'm just teaching you, how to derive these things, and this is completely mechanical. when we do it in the class, in next week as an exam, I'm not going to give you long conditions like this. Otherwise, just the copying part is going to take up too much time. But it is important to understand the concepts in this case. Yep.
So just to be clear, when we do the post of the entire script, you want it expanded. You just don't want post 2 or post 4. You want actually what?
Yeah.
Okay.
Yep. Just expand it, so that we can actually see how the variables relate to each other. It won't be anything like this long, but it will be. But you do have to kind of copy and paste it. Yep.
Can you show the original algorithm again on the?
Yep. That's the algorithm.
So at the very end, you have to do a post 5.
Yes.
Okay.
Yep.
Are you gonna upload this today?
Well, if I remember to save it first, I forgot to save it on Tuesday. When I shut down the machine, it's all gone. I mean, there's no way to rescue it. All right, so at least this part is saved. But I have to save one last time at the end of the class. Otherwise, whatever I type from here on to the end of the class, will not be saved on the disk. All right. Yes.
Just basically, when you have an else or an else if, you never usually use a post line item number for that. Why did you use a post 5 if it lands on an else if?
Why do I use?
According to your example,
Right.
statement number 5 is and if, correct?
Yes.
And then you have a post 5.
That means, what do we know immediately after line 5?
Got it. Okay.
Yep.
Why is it post 1 necessary? The or, it's either one or the other, or it's either the condition or it's
You mean
not the
here?
condition.
On which line
Post
are you referring
1,
to?
no, I'm saying why is post 1 unnecessary?
There's no post 1 because when you say pre 1 and post 1, you are implying post 1 is naturally following. When after you execute line 1, that's the next state. Okay, what's happening after line 1? But in this case, line 1 splits into 2 paths.
Okay.
So you cannot say, oh, after line 1 executes, it's always like this, because there's no such thing as always. It depends on the evaluation of the condition. Sometimes it goes this way, sometimes it goes the other way. That's why I cannot refer to pre-2 as post-1, because line 2 does not always follow line 2 does not always follow line 1 anymore.
Sure, but since it does go down that path, before it gets to that fork in the road, it says, you could say that it's true that either x is greater than or equal to y, or not greater than or equal to y.
Well, that's why pre-2 handles the case when the condition of the conditional statement is true, and then pre-4 handles the case when the condition of the conditional statement is okay. The other one,
Not
the
true.
first one handles it when it's true, and then the second one handles it when it is false.
Okay.
But we have to separate it into 2 cases because that's the nature of a conditional statement. It splits one path into 2, so you cannot say that this path is always going to happen or this path is always going to happen. Any question? I thought, okay, no questions. Yes, go ahead.
One more quick question. Does pre or post 1 always have to equal pre 2? Not necessarily just in the specific one, but just in general.
Post, if the statements are sequential, then yes.
Yeah, yes.
Yes,
Okay.
but in this case, they're not sequential.
So,
Right. Any other questions about the?
Can you scroll down just for 1 second?
Yep.
Okay, thanks.
The rest is really just mechanically applying those rules and deriving the result because of the substitution operation. Yep.
So we don't need a pre-5?
There's no pre-5, because once again, when you say pre-5, you are implying that post-5 is a result of line 5 executing, but that's not the case.
Okay.
Because line 5, for one thing, does not execute. It doesn't do anything. but it is a marker to mark the end of the conditional statement. So you can say something. You can say something about post 5 because you can say, okay, what do we know for sure when the conditional statement is completed? And that's why post 5 still makes sense, even though pre 5 does not make any sense. And in the homework assignment, I actually stated you need to explain and derive exactly what you need to derive. So you can see that on this list here, there's no post 1 or pre 5. Yep.
Can you go back to the notepad and can you expand it just a little to the right?
To the right. Oh, to make it.
Oh, thanks.
Yep.
Do you put like post how many points each assignment's worth? I haven't seen it, so it only says like 100% and that's it. Like it doesn't say like they're worth 30. It doesn't say how much they're worth 5. Like which homework assignment's worth. I didn't see it. Is it
I
on there?
think it's stated somewhere
In the grades,
in the grades.
yeah.
Okay. Oh, there you go.
There's no grades.
Yep. I cannot check your grade because I
Okay.
cannot show the grade of somebody in the class. Yeah, district will come after me if I did that. It's a privacy issue. I can pretend that I'm a student and show you my grade, but I'm not sure whether you will see exactly the same thing in that case. So I can switch my role to a student, and then I can show you my grade. Okay, so you can look at some of the homework assignments. And it doesn't show the number of points.
You're failing.
That's interesting. Why? It doesn't show the point value.
It doesn't show the point value. That's all I'm saying. Like,
It shows, John,
Go back to
see
the assignment.
where it says 52 out of 50?
You mean
No.
the previous one?
Yeah. Where it says 52 out of 50, next to your assignment, there's going to be
Oh,
how
that's
many
right.
points you
Okay.
got.
So so for that assignment, it will show you how many points you got out of how many. Yep. Yep.
you don't know beforehand, like beforehand you're doing the homework.
If you want to know, I can tell you, right away.
Oh.
Yeah. When you can ask me in the class, I can tell you. Yeah. All right. Any? Yep.
How much was the nested loops?
The nested loop one. Let me see. I can look at the assignments. Go to the nested loop. This one. It doesn't show here either. Yep.
I don't think the 50 was the grade.
Yeah, I think it didn't. Well, I'm still in the student role, so I cannot, I
Yeah,
have to
for me,
return.
everything just says 1 of 52.
Okay. Oh, that's ranking in the class.
Oh.
That's how you rank in the class. So the smaller the number, the better.
Oh, really? Not bigger?
Not bigger. See, I'm 52 out of 50, which means I'm officially below the last student in the class. Because there are 51 students in the class, and I'm 52. It's ranking. You cannot see each other's ranking, but you can see your own ranking. For each homework assignment, you can see your own ranking. I wouldn't pay too much attention to it. If you're getting 80%, 90% or so, I wouldn't pay too much attention to your own ranking. On the other hand, if you're kind of getting a lower score, you probably want to pay some attention to the ranking, because that really shows you where you are in the class relative to your peers. So that's a pretty useful indicator. And some people, getting close to 100% all the time, they pay a lot of attention to the ranking too, because they want to go, I don't want to be number 2, I want to be number 1. All right, so let's go for the practice exam, because that's actually the most important part of this class is the practice exam. So let's go ahead and magnify this a little bit. The basic instructions would be about the same for your exam. You don't have to do this step anymore, because what I would do is I'm going to print, lined portions, on a piece of paper. So the question will be on the top, and then I will give you the empty area to write your answers. So it simplifies, a few things. One, you don't have to bring your own paper. I would still bring some additional paper, just in case you run out of space or you want to scratch everything and start from scratch. But for the most part, I will give you the space to write down your own answer, so that way it's easier for me to grade. Definitely, you want to write down your name and your student ID. the date and the course code. The course code is probably printed on the paper already, but you definitely want to write down your name. Otherwise, I can grade it, but I don't know who will have, who should receive those points. As far as meeting time is concerned, it's not important this semester because this is my only section for this semester. Last semester I was teaching 3 sections, so that was important. Write legibly. That's really, really important. Make sure that I can understand what you're writing. You can include diagrams if it helps you. In other words, you can draw additional stuff, but I cannot grade based on your diagram. So I have to grade based on what you write in as the answer. If you need multiple pages, indicate the ordering. So you have to say page 1 of something, page 2 of something, and so on. I will try to bring my own stapler. So at the end of the test, I will help you staple everything together. The total number of points is, okay, this is for last year. The whole test has 60 points, which makes up 20% of your final grade. But that's in the syllabus already, and all of you have already acknowledged that you have read the syllabus. So this is something that you know already about the 20%. Any printed or handwritten material must be, you are allowed, okay, what is allowed in this case? You can bring anything that is printed or handwritten prior to the test. I have to state prior to the test because I don't want someone to pass a note to somebody else and say, but you said we can use any printed material or handwritten material. So I just handwrite something, I pass it to my buddy next to me. So that would not be allowed. Yes.
Test Tuesday or Thursday?
Sorry? The test is on Thursday, next Thursday. So you have 1 week from today will be the test. So if you have any questions about the material that will be on the test, you still have Tuesday to ask. So my advice is study as if the test is on Tuesday over the weekend. So this way you cover all the material, and if you have any questions about the material, bring it on Tuesday. So that will be your last chance to ask questions. You can use calculators, but only for the purpose of arithmetic calculations. I think adding 1, subtracting 1 should be okay for most people. So I don't think a calculator is really needed. You can bring dictionaries if you want to. Answering questions out of order is okay. That's not a problem. But make sure your answer does indicate the correct question number, especially if you attach additional sheets of paper. What is not allowed? Any electronic devices, such as laptop computers, cell phones, Nintendo DSs, and so on and so forth. Okay, so if you bring your cell phone, that's okay. You have to keep it in your bag, and it has to be silenced, because I don't want it to be a source of distraction to other students. Any questions or issues about this one? No? You guys are good. I usually get some argument like, but this gives me a handicap because I'm so used to using a computer. Doing things on a piece of paper is a handicap. No, it's not. We'll all do it on pieces of paper. Live communication during the exam regarding the material being tested is not allowed. General grading methods, points are rewarded based on the demonstration of the understanding and application of techniques, methods, and material introduced in the class. In other words, if I ask you about, okay, let's derive the post condition of these 3 statements or something like that, if someone gives me the final answer and the final answer is 100% correct, that person will get 0 points because it does not show the steps. The steps are actually more important than the final answer. On the other hand, if someone followed the steps, made a mistake early on, step 1 has 1 silly mistake. Okay, a greater than becomes a less than, or forgot about the negation or something like that. I will take point off for that particular step. But if all the subsequent steps are still correct and is shown step by step and everything is consistent, that person will get close to 100% for that particular question, even though the final answer is incorrect. Okay, so I want to make it very clear so that I don't get any arguments later on and say, how come my answer is right but I got 0 points? I need steps. Okay, I need you to show me why or how you get to the answer. Which is the next point here. Okay, so I'm just repeating myself. Code tracing standard, basically everything that we have done in this class already. One column for comments, okay? Because if you have conditions, you have to tell me the state of the condition. Is it true or is it false? One column for line numbers, one column for each variable in the program. And I state here, how, and you have to indicate changing from 0 to 0. As long as there's an assignment statement, you have to indicate that it can potentially do some changes to a variable. You have to use a pre-row to indicate the precondition of the algorithm and a post-row to indicate that that's the end of the trace. Is there anything new here that we haven't talked about? Okay, very good. Pre and post condition derivation. It's kind of bad that I cannot show you the entire row. Pre and post condition derivation standards. Explain to me why you use the sum or the forget, just like with the homework assignments. Explain how the post condition of one statement connect to the previous one if they are sequential. Okay, so nothing new. Everything that we have talked about in the class. There should be no surprises here. So here are the actual questions. Let me do it like this. Okay, the first one is code tracing. In other words, I give you an algorithm. I give you a test condition, x equals 300 to begin with, y equals 298 to begin with, and you have to trace this algorithm. Okay. Any question about the type of question here? Let me go over each and every single question just in terms of the type, and then I'll come back and talk about the answer. The second one is about pre and post conditions. Step by step with explanation. Derive pre-2, pre-4, post-2, post-4, and post-5 of the following algorithm. Does that look familiar to you?
Yes.
I hope so. Because we just did something very similar to this. Not exactly the same, but similar. Very, very similar. Question number 3, more code tracing. Go back to the code in question number 1. This time, change x to be 300 to begin with, change y to be 300 to begin with, and if you think the code results in the execution of an infinite loop, indicate so and briefly explain why. Now, because I attached this statement, doesn't mean that it is going to be an infinite loop. I'm simply saying if it is an infinite loop, you have to tell me why it is an infinite loop. Okay. Number 4, reverse reduction. Okay, so this is the kind of thing that some people do not really like, and it's really just a twist of our usual pre and post condition, because in this case I give you 3 lines of code, just like most of the time, but this time I tell you that post 3 is this condition. So we are going backwards. Okay, we start with the post condition of 3 lines, and then you have to go back to pre-1. And then after you get back to pre-1, you will have to go forward again to prove that your pre-1 is in fact the correct answer. So we'll deal with that when we get to question number 4. Yes?
It says you don't need to use formal proof, so we don't write as many lines. We
When
just
you're going
briefly
backwards.
Explain.
Yes, correct.
So how many lines per line are we? 1 or 2, just saying, here's where we would take one off or whatever.
Yeah, well, you just have to explain, why, how you derive the precondition of a line from its post condition.
Like in our own words.
In your own words, yep. Mm-hmm. Now remember, I can change the form of these questions. In other words, the questions that you guys will get will be very similar to these, but they may not be exactly the same. I can change the form. I can give you a proof. I can give you the derivation, of the pre and post condition, and I can intentionally make a mistake. And your job is to spot, where did I make that mistake? Okay, it can be something like that, which is in a way is easier because that way you just have to follow my logic until the point where I make a mistake. But in a way it is harder too because you're trying to find a mistake instead of actually going through the derivations yourself. All right, so let's start with the most difficult one. Okay, let's start with question number 4. Question number 4. Okay, I'm just putting all the answers to the text file for today. Q4 of practice. All right. I'm going to copy and paste this portion so I don't have to do it by hand. It does a pretty good job copying and pasting too. I'm changing the symbol so that you can open it in your WordPad application. All right. What do you think I can say before line 3 executes? Based on post 3. Yep.
So we don't know what Z was before?
Exactly. Because the operation is irreversible. I cannot start with Z having a value of 0 and then be able to go back and say, oh, before line 3, Z must have this other value. So I cannot say anything like that. So that means I can keep everything else except anything that mentions Z. Okay? So your explanation can be just, because the right-hand side, okay, all you have to do is to say because the operation of line 3 is not reversible, so we don't know what Z was for line 3. So it can be just in your own words, explain to me, why are you getting rid of Z equals 0 in post 3? Yep.
Could we say Z equals question mark?
No, just get rid of it in the conditions. Okay, so now we can say post 2 equals pre-3 because line 2 and 3 are sequential. Okay. So now we know post 2 is pre-3, which is this mess here. So the question is, can we say something about pre-2? What do you think pre-2 should be? Well, let's take a look at line 2. Line 2 says y gets x plus 1, and as a result, y becomes k plus 1. The question is, can I go backwards and figure out what was y before line 2?
K minus 1.
Hmm?
K minus 1 would be y before.
The answer is no. The right-hand side does not refer to the left-hand side, so there's no way the operation is reversible. If the operation is not reversible, I cannot go back and deduce the value of y or even how it relates to all the other variables. So basically, it's the same deal. You have to say the precondition of line 2 is just that x equals to k. And the reason is exactly the same, so I'll just copy and paste. Because the operation of line 2 is not reversible, so we don't know what the value of y was before line 2. Same reasoning. So now we are going back all the way to line 1. We can say pre-1, post 1 equals pre-2, because line 1 and 2 are sequential. Okay. Pre-1 is what? Okay, let's take a look at our current situation. We know that post 1 is x equals k for some value of k. The question is, if x equals k after it gets incremented, do we know anything about, if x equals k after it is incremented, do we know what the value of x was before it increments?
Minus 1.
Minus 1.
Yep, it's k minus 1. So here we can say x equals k minus 1 because line 1 is reversible after the increment x equals k. So before, I'll break the line. The increment x equals k minus 1. So something like this, would be sufficient. Is that making any sense? But I can change the form of the question. I can make it so that you don't have to explain how you get back to pre-1, but you have to start with your pre-1 and go forward to get back to the same post 3 of the question. Okay? So I don't care how you get your reason, how you reason your way back, but you have to prove that your pre-one is correct.
Where do you get the K?
Go ahead.
Why does x equal k minus 1 instead of k equal to x minus 1?
I don't know how to do that.
Okay, we know that after line 1, x equals to k, right? It's because of this line here.
Right.
Pre-2 is x equals k, and post-1 is the same thing. And all line 1 does to x is to make it 1 larger than before. So after we increment, it becomes k, so that means before it increments, it is k minus 1.
But would it not be the same to say x minus 1 is equal to k?
X minus 1 equals k would be the opposite direction.
X plus 1.
X plus 1 equals k is the correct way to say exactly the same thing.
Okay.
Yep. And you had a question too? No? Okay. Does anyone want to do one like this, but with conditional statements, going backwards?
Oh, no.
There'll be one in the final exam, so we'll save the good stuff here for the final exam.
They will be going backwards. Going backwards with it.
Yeah.
Okay.
Yeah, you can have a conditional statement. If I tell you what is the post condition at the end of the conditional statement, you should be able to go backwards, just like with the other stuff too.
What if there's an extra loop in it?
I won't ask any questions about loops as far as pre and post conditions are concerned.
So there'll be an if then, but reverse.
Yeah.
Can we see an example?
Well, it's going to be in the final exam, so
Oh, the
so this
final.
test won't have it. Yep. Okay. Any questions? Unless you guys request it, I can make it happen too.
No, it's okay.
Uh-oh, it won't convert. So did it actually save it or not? Okay, so which character could it not? I think it's the double quote. There we go.
Wow. Good eye.
Well, if you have done this, for so many years, you know all the typical stuff already. Okay, I don't think Q2 really needs explanation because we have just done that or something similar to that. So we'll go ahead and just go with question number 1. Question number 1 is your typical trace thing. I will give you, the lines and the grids and stuff like that, so that way you don't even have to line everything yourself. So let's go ahead and do this part. And after the test, when you guys talk to each other, you will find that, there will be like different versions of the test for each question. So I typically make 4 or 5 variations of the same question. So there will be like 4 versions of question 1, 4 versions of question 2, 4 versions of question 3, and 4 versions of question 4. But then the intermixing of these 4 variations of each question is randomized in a big pile. I don't even know ahead of time how everything is going to be arranged. So so that's why when you talk to each other after the test, don't be surprised if your next if your neighbor gets a question that is different from yours. Because I get that a lot, when people try to kind of check the answers after the test, they go like, oh no, which test did you take? It's the same test. Okay, so in this case, I'm not even going to bother to copy the algorithm because I can see it here. So we'll just go ahead and start with comments because we have conditions. There's a conditional statement and a while loop here. And we have line number, and then we have 2 variables, in this case, x and y. It is important to remember what is the precondition of the algorithm. And then we start with the values given to us. X is 300 to begin with, y is 298 to begin with. So we have 300 and 298 to begin with. And now we can get started with the trace. Okay. Line 1 doesn't really change anything, but it does evaluate the condition. X is greater than y is true. And as a result, do we make any changes to x or y? Where do we go? We go to line 2, very good. And what is line 2? Line 2 is the beginning of a loop, so we have to ask the question, y is less than x is? It's true. It's the same question, just I changed the order. Okay, so that's why we have to go to line 3. In other words, we go from line 1 to line 2, not because it is sequential. It is because of the structure of a conditional statement. We go from line 2 to line 3, not because it is sequential, but because it is a loop. Okay, so you have to make sure that you understand that even though it looks like, oh, line 1, line 2, line 3 is because they're sequential. No, we haven't used anything because they're sequential yet. In fact, there won't be any in this case. Y gets y plus 1, so we go from 298 to 299, and then where do we go? 2. Go back to line 2, because this is a loop, and we have to ask the question again, y is less than x is still true. We go to line 3 again, this time y becomes 300. We go back to line 2, it is now false, and where do we go next? Line 5, okay, don't forget there's a line 5 here. This is the only time when it is actually sequential. The loop is right before the assignment statement. And x gets reset to 0. And where do we go next? Go to post right away.
So the only way to get out of loop is if it's false.
Yes, because while is the same as long as. Okay. Are there any questions about this trace? No questions? Yep.
Line 6, we don't have to put it. What happens if we put it?
What? Row 6?
Line 6.
Line 6?
Instead of just post, you go to 6.
We don't say line 6, because it is ambiguous. When you go to line 6, do you mean that you actually go through the then portion, and as a result you get to line 6? Or did you skip the entire portion of the then and you get to line 6? It's not clear, and then we don't trace line 6. Yep, go ahead. Back there. Yeah.
Go back to, remember back to line 1, it's false.
No, because it's not a loop. It's a conditional statement. It's a one-shot deal.
Oh, yeah.
Yep.
That was my question.
Yeah, we do not go back to line 1 because this is a one-shot deal. With a conditional statement, you get to line 1 only once, and then you split the path. One path is actually empty. Your else path is completely empty. It just skips all the way to the end. Your then path has something to do, but after you do that, you don't go back to line 1 because you exit right away.
Okay, so if the precondition for the beginning of this was x equals 299, x equals 1.
Mm-hmm.
So that makes line 1 false.
Yep. Well,
Just go straight to post.
Let's take a look at question number 3 because that will answer your question. Okay. Question number 3 is basically looking at question number 1 again for the code, but this time you start with 300 and 300. Okay. So we'll go back to the trace, and I will copy and paste this portion to the next sheet, so that we capture that one as a separate sheet. Because this time we start with 300 and 300. So we start with line 1 again. Line 1 is still asking the same question. Let me throw back to the question here. So line 1 is still asking the same question. X is greater than y is false. It's false to begin with, so what do we do?
Post.
Go straight to post. Okay?
Well,
So yeah, go ahead.
and the only time line 5 gets executed is when you go through the loop at least once.
No, the only time line 5 executes is the loop executed, and exactly. It is possible, if I change the conditions, it is possible to get into the conditional statement, but not go through one iteration of the loop. So it doesn't matter whether you go through iterations of the loop, as long as you get to the loop, line 5 should execute, unless the loop itself is infinite. Yep. Question?
What would we get on the score if we went back to line 1 in the first example and said false and then end if?
Well, the way I grade something like this is based on, does a person demonstrate to me that that person understands the mechanical aspect of a conditional statement? If someone shows me, to go back to line 1 right at this point, that means that person did not actually have a solid grasp of the concept, and therefore the points will be deducted because, for that reason. Not a whole lot, but some points will be deducted if someone shows me that it's going back there. And also for the same reason, if someone shows me that these lines are missing, or these rows are missing from the trace, that means that person did not fully understand the concept of a loop, because a loop always has to go back to the beginning to exit the loop. So for those reasons, that person will also get points deducted because I'm looking for demonstration of the understanding of the concept.
Oh, okay, I got it.
And also some points will be allocated to the details, so you have to make sure that you increment the values correctly and evaluate the conditions correctly as well. Yep.
Line 1 does not say while, it just says.
Correct. Line
You
1
never
does
go
not say
back to
while.
it. That's what you're saying.
That is correct. Okay. Are there any questions about question number 1 and question number 3? Because those two are kind of related. It's just that they have different test cases. No questions? So we only have question number 2 remaining. You guys want me to do it?
No. You just did it.
We just did something, I think, what we did was actually a little bit more complicated than that. Okay. So once again, yep, go ahead.
Is this about how long the test will be?
How about this? I'll just say that this was how it was in spring. Because if I say anything else, someone's going to hold me accountable and say, but you said our test is going to be like this. No, I said this is what we had in spring. So I don't want to be held accountable for stuff like that. So I'm just showing you what it was in spring. Your test will be different. That's all I can say.
It doesn't have to be.
You could just give us that.
And
Less
it won't
work
count
for
for
you.
any points of your final grade. Yes, we can do that. Yep, go ahead. Any other questions about the material that we have talked about? Let's move on and talk about something that we actually have seen, but we haven't put those two together, okay? Because that's also one of the things that you will find in my classes. A lot of times I'll give you A, I'll give you B, and I'll give you C. I talk about A, I talk about B, I talk about C in the class, but I never talk about what happens when A and B combines, or when B and C combines, or when A and C combines, or when A, B, C all combine together. Okay, so a lot of times I ask questions with that sort of thing in mind, because if you truly understand A, if you truly understand B, and you truly understand C, the combination should not bother you. So let's take a look at that combination here. And okay, and this is also a good illustration. I think I promised you that I will show you what is a dead branch, what happens, or what does it mean when the precondition of a line is false to begin with. Because that seems kind of odd. I mean, why would the precondition of a line, pre-something, be false? Yep.
Like if you're asking the hour of the day and it was outside of 0 to 24 or something.
No, not like that. We'll take a look at an example. Okay. So else if, so this is a multi-branch conditional statement, which we have talked about. We just have not talked about it in the context of pre and post conditions. So we'll say x is greater than z. Let's change it to w. All right, so here is our multi-branch conditional statement. And we'll go ahead and talk about the pre and post conditions for this one. In this case, let's just say that we don't know anything about W, X, Y, or Z before this algorithm starts. Okay? So the question is, what can we conclude at line 9? That's the question. What is post 9 in this case?
C is 0, 1, 2, or 3.
we know what z can be, but that's not enough. That's not the post condition. The post condition is actually a little more than that. Well, let's apply what we have learned so far. Can we say something about pre-2? In other words, if I am about to execute line 2, what can I say?
X is less than y.
Okay, so we'll start with pre1 and x is less than y. Okay, because pre1 still has to be true. I have not had a chance to change anything at this point, but I have just confirmed that x has to be less than y. Otherwise, I would not be about to execute line 2. So this becomes true, and x is less than y, and it simplifies to x is less than y. Is that okay so far? Okay. So post 2 is actually pretty easy. I'm gonna skip. Tag is lazy and skipped some steps. Don't do this. Disclaimer. So post 2 is fairly easy. It's just a forget rule. We're gonna forget everything that we knew about z, but there's nothing that we stated. We didn't state anything about z in pre-2, so there's nothing to forget. So as a result, the post 2 is just x is less than y and z equals 0. Okay, I skipped a few steps to get to that conclusion, but it makes sense. Okay, what about let's see. What about pre-4? What can we say about pre-4?
That.
Now pre-4 is a little bit complicated this time, because if I am about to execute line 4, what has to happen?
X can't be
Okay,
less than y.
correct. So pre-1 still has to be true, because to get to line 4, I have not had a chance to modify anything yet. So pre-1 still has to be true. What about x is less than y?
It's not.
It has to be false, because when you have a multi-branch conditional statement, you evaluate the conditions in the order listed, top to bottom, when you look at the listing. So x is less than y has got to be false. Otherwise, I would not be here. And what else can I confirm when I am about to execute line 4? X is greater than w has to be true. Okay. All right. So we just plug it in. We simplify. And then we just copy in this case. And then we simplify one more time. X is greater than or y, and x is greater than w. Fine, that's not a problem. So post 4, if I, using my lazy way, I just go ahead and say, okay, all of this can be preserved, because the only thing I have to forget would be things that I said about z, but I didn't say anything about z, and as a result, there's nothing to forget. But at this point, after line 4 executes, z equals 1 for sure. Okay, so post 4 is, just the application of the forget rule. Let's look at the tricky one. What about pre-6? If I am about to execute line 6, what does it mean?
It can never be reached.
It can never be reached, but let's go ahead and try to figure out the precondition anyway. Pre-1 still has to be true, because I have not had a chance to modify any of the variables. X is less than y has to be false, because otherwise I will be executing line 2 and get out right away. What about x is greater than w?
That's also false.
That has to be false as well, because otherwise I would have executed line 4 and gotten out already. And what else? X is less than y minus 10 has to be true. Otherwise I would not be executing this branch.
But that would mean x is less than y, so we never get there, right? That's what.
Well, yes, that's what we want to come to as a conclusion. But I want to show you, how you can show that we can never get here. There's a difference between well, we kind of have a gut feeling that we'll never get here, versus I can prove to you that we'll never get here. Okay. So pre-6 is this mess here, and conjunction, the and conjunction is just like multiplication, which means you can use commutative law to change the order of conjunction. So what I'll do is I'll change the order just a little bit. looks like that. And then I use the associative law to say that I will evaluate these two first. The first two. So I put extra parentheses here. Oops. All right. Does anyone see a problem here? X is greater than or equal to y, and x is less than y minus 10. Is there a problem?
Can't be.
It cannot be both true, right? But we haven't taken any classes in Boolean algebra. But does that make sense? I mean, does it make sense that these two cannot be true at the same time? Only one can be true. So if it cannot be both true at the same time, and this is a conjunction, what does it tell you about the result of the conjunction?
That's false.
The conjunction has to be false. Okay, all right. So this whole thing becomes false. And then we have false and x is less than or equal to w. Is there anything I can do here to simplify this?
Make it false.
The whole thing has to be false. Because if you know that one side of a conjunction has to be false, the entire conjunction has to be false. Yep.
If it was y plus 10 instead of minus 10, it could have been true, right?
If it were, y plus 10, then yes, they can still be true. So I picked, y minus 10 for a reason, so that this has to be false. Now, what does it mean when pre-6 is false? This means line 6 is not reachable. When you execute this algorithm, regardless of the values of w, x, y, and z, you can never get to line 6. And line 6 is also called a dead branch because of this. In other words, we talked about dead branches before. But this time, I talk about dead branches, and I can prove that something is a dead branch because the precondition is false. When the precondition is false, that means there's no way we can get to this line. Is that okay so far? Now, of course, yep, go ahead.
So is it there as a mistake, or?
It is most likely a mistake, on the part of the programmer. But since I do not know exactly what the algorithm is supposed to do, I cannot tell you how to fix it. It is possible this is still correct, because the behavior, the expected behavior, it may be the case that z should never get a value of 2 anyway. So having line 6 as a dead branch is not wrong, but it is definitely
Waste of space.
well, it's a waste of space, and it's also confusing. If you have a branch like this, most people will think that, okay, maybe in some cases we'll get to line 6, but in this case, there's no way we can get to line 6. Okay, just to finish this off, okay, what is pre-08? That's just, kind of clumsy because we just have to do all the conditions, and they all have to be false. Pre-1 still has to be true because if I am about to execute line 8, I have not had a chance to modify anything yet. So pre-1 still has to be true, but every other condition has to be false in this case. So we'll have to say x is less than y has to be false. X is greater than w has to be false. X is less than y minus 10 has to be false. I don't have a problem with this, okay? How do we simplify this? True and x is greater than or equal to y, and x is less than or equal to w, and x is greater than or equal to y minus 10. We already know that true and something can be simplified out. Let's take a look at the next 3 and see if we can simplify something here. And once again, we'll use the commutative law and change the order of these comparisons so that we can put related items next to each other. So we put it here. Get rid of it here. All right, can someone tell me, is there a way to simplify this? X is greater than or equal to y, and x is greater than or equal to y minus 10.
First two.
We can get rid of one of them. We know that they are closely related, but which one can we get rid of?
First one.
First one.
We can get rid of the first one.
The second one's more specific.
The second one, because it's greater.
This goes all the way back to the if and only if, sufficient versus necessary, and stuff like that. Yep, go ahead.
Because the first one's reiterating what the second one says. 'Cause- right?
Okay. Do you guys know what this diagram represents? We have cases like this, we have cases like this. This is the intersection, right? The intersection is basically the end of those two, the overlapping portion. So now if you look at this one here from the perspective of a number line, okay, so let's just say that we have x is greater than or equal to y. So x is here, and y can be the same point, or y can be somewhere here. Okay? So where's y minus 10?
Down there.
Y minus 10 is here. The first statement says x is greater than or equal to y. Okay, for all cases where x is greater than or equal to y. So that means we are looking at this portion of the number line. The second one, which says x is greater than or equal to y minus 10, means we are covering this portion here. Okay? So the question is, what is the intersecting part of these two number lines? The overlapping portion is here. And we can only keep the intersecting portion, so that means which one do we keep?
Y minus 10.
Well,
The first one.
the first one. We can only keep the first one because it is more specific than the second one. It is also, you can also explain it like this. You can also say that x is greater than or equal to y implies x is greater than or equal to y minus 10, and therefore the second condition is redundant, and therefore it does not need to be there. X is greater than or equal to y, this number line, is a necessary, is a sufficient condition for the other one. If x is already greater than or equal to y, it is automatically greater than or equal to y minus 10.
You would include y minus 10 if it was or? Sorry.
That is correct. Yes, when it is an or, then you go for the more general case. If it is an and, you go for the more specific. Yep.
So that's just considered simplification. That's not required. in the exam.
That is not required. Yep. But you should also see that there's no conflict whatsoever. In other words, when you get to this part here, which is just completely mechanical, well, this part is completely mechanical, but you have to get to this part here, and there's no conflict. It's not false. Okay? So as long as it is not false, you still have to derive what is post 8. So in this case, post 8 is just that condition. And z gets a value of what? Is it 3 in this case? Yep, z is 3. All right, so now we want to derive what is post 9. What do you think is post 9? Just look at the code here. It's a multi-branch conditional statement, and the only difference between a multi-branch conditional statement and a regular conditional statement is you have more than 2 branches. Okay, it looks like this. You have a branch here, you have another branch here, you have another branch here, like that. There may be something to do here, there may be something to do here, maybe something to do here, maybe something to do here too. But what do you do after you have done this, 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 or this? They all merge and exit together. Okay, so they all merge, and we have one single big exit. So if I am standing here, what can I say? I know the post condition of this, I know the post condition of this, I know the post condition of this, I know the post condition of this. When I'm standing here, not remembering which way I came from, what is the statement that I can make here? Any of it, the disjunction of every single post condition. So that's why we can say, that's why here we can say it is post 2 or post 4. Or guess what? Even post 6 should be here. It doesn't matter. It doesn't hurt to say or false, because anything or false is just anything. It doesn't do anything to hurt the disjunction. But in this case, we also have a post 8 the next thing you have to do is to just copy and paste, all those things, and potentially simplify, post 6 is false, so we just, it doesn't do anything to the whole expression. Is that okay? So this is what I meant, this is what I mean when I said, I will give you A, I'll give you B, and sometimes I will assume that you can combine A and B. This is a combination of a multi-branch conditional statement. We talked about that, we traced that, and the derivation of pre and post condition. And they're similar enough that I think, this would not be something too much to expect. Yep.
On this following exam?
No. But in general, I think people should be able to put A and B together and know how to extend something that you knew already to cover something that we have not, we haven't talked about the combination, but we have talked about the individual pieces already. It takes some understanding. You really have to understand the basic concepts of the structure of a multi-branch conditional statement and the meaning of the pre and post conditions. But once you have complete understanding of those two, you can combine those concepts together and handle a multi-branch conditional statement using the pre and post conditions.
And you're gonna say right.
That's a good reminder.
Test right there. Yeah.
Hmm?
I'm bringing that to the test. I'm printing it. Right?
I can give you something like this and put a dead branch somewhere else, and you have to figure out where the dead branch is. Any other questions? What is the simplest dead branch?
False.
That's it.
Pretty
I want to give
false.
This line here is a dead branch. Because in order to get here, the condition of the conditional statement has to be true, right? When can false become true? Never. There you have it. That's the simplest dead branch I can give you. But there can be more complicated dead branches too. If I give you a multi-branch conditional statement like this is just a general question. Is it possible for me to structure this so that this is a dead branch and make this one a dead branch as well? Can I just arbitrarily pick 2 to be dead branches and can I structure the conditions so that I can pick any 2 dead branches to become dead branches?
Yes.
The answer is yes. Okay, so dead branches are not always something other than the first one. I can make the first one dead branch just by saying if false then blah 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 blah, else if blah blah blah, so that the first one is dead right off the bat. Okay, I can make the last one dead branch too if these 3 conditions, this one, and this one, covers all the possible cases, then the last else has to be a dead branch. Okay, so I can structure my conditions to be for any conditions or for any branch to become a dead branch. Can I make all 4 branches dead?
Yeah.
If false, blah blah blah, else if false, then blah blah blah, else if false, then blah blah blah, else. Oh, but that last one is not dead anymore. Right? The last one is an undead. It's a zombie. Because if I make this condition false, that forces me to go this way, right? If I make this condition false, it forces me to go this way. If I make this one false, it forces me to go this way. Guess what? It is no longer dead. So maybe it is not possible to make all 4 branches dead. When you have else, when you have one final else, then at least one branch cannot be dead. Okay? Any questions? Well, go ahead and study. Okay, use this weekend to study as much as you can. On Tuesday, bring your questions to the class, because if you don't bring questions, I'll move forward and talk about hierarchical coding and structured programming. So you got to make sure that you study and bring your questions. Yep.
Did you do the brain teaser from last time?
Brain teaser?
Yeah, it was the I can't remember exactly what it was. But,
Okay, I can probably do a little YouTube thing just to cover the brain teaser, but send an email to me to remind me.
Okay, okay.
Yep.
What's that? Oh yeah, I did read it.
Is there gonna be homework on Tuesday, or would you?